Okay, last video. So for this, we're told a few things about this function. We need to write it in factored form, standard form, in behavior, all that good stuff. So its leading coefficient is -2, and then its roots are -2, so that would be x plus 2. And then it has two 1s, so that'd be x minus 1 squared, because it has multiplicity. Okay, so it has a degree of 3, but at the moment it's appearing to be only 2, but you'll see why it is actually a degree of 3 in a minute. And you'll see that when we turn it into standard form. So what we need to do when you're doing this, don't try to just multiply this thing out to standard form. No. Doesn't work. That was it, right? Yeah, except a different blue. Okay, so you have to take it one little piece at a time. So you're gonna FOIL first. Okay, now we've taken care of this. Now we have to multiply it by x plus 2. So now we do distribute, okay? And by that I mean we run x through. There's our degree of 3. And then after we do that, we have to run 2 through. Okay, and then lastly, we need to multiply by -2. Let me just double check that. Always double check your work to make sure that you didn't make a small mistake anywhere, especially when I can't pause the video, but it's looking good. Okay, now we're going to combine our like terms. So we got -2x cubed, and then what I do is I just and then I'm going to combine that and that, which take care of themselves. And then I'm going to combine this and this to 6x, and then take away 4. Okay, so what we have to do now is we have to work through and we have to get like all of the other necessary stuff that they require for us. So here we go. End behavior. So this is like f of x. Okay, so it's to the third power. But it's a negative in front of the third power. So usually with an odd one, remember, it's just, if I think of my basic something to the third power, actually I'll even just draw it on the graph for you. If I just have like x to the third, something like that, right? So as I go this way, it dives down to -infinity, but that -2 switches it to something like this, which means that this one is going to go up. When we go towards -infinity for x, the graph goes up. And when I go towards positive infinity, it's going to go down. Okay, so now we need to graph this thing. So let's think a little bit about its roots. Well, it's got a root at -2, and it's got a root at 1. We got that, which is nice. And then we just need to think about everything else. So what other dots do I know? Well, I know the y-intercept. Okay, and on the test, it's going to be real clear what points to mark. It's going to say mark the roots, but it's also going to tell you to mark the y-intercept, which this one doesn't, but the y-intercept is -4. We know that because if we plug in 0 to the standard form equation, or really, if we plug in 0 to either equation, it's going to give us -4. And now we start thinking about end behavior. Well, what did I say? When it's going this way, what's it doing? Is it going up or down? It's going towards infinity. And as I go this way, what's it doing? It's going towards infinity, okay? And it's going to have a little curve to it too. Okay, but basically it would look something that's kind of similar to that, okay? And just to be sure, I want to plug this into Desmos to just kind of see what it looks like. So I have negative 2x cubed plus 6x minus 4. What was it, minus 4 or plus 4? It's going to be plus, no, minus, because it had a y-intercept of negative 4, right? Whoa, what did that do? Okay, there it is. So how did we do? I think we did pretty good, right? So we got that, and then we got that, and it's going down in that direction, right? Oh no, I made a mistake. I'm not sure how that happened, but I'm not going to restart the video. Probably picked up on it. So as we stated right here, sorry guys, it's been a long day. As we're going towards infinity, we said right here it's going to go down towards negative infinity. So this is going to come up, it's going to touch right there, and it's going to come back down. And it would make sense that this would be two answers, because that's how we spot multiplicity on a graph. So it comes down and it just touches one time, right? We don't need to know anything else too exact other than that. That's more, pre-calculus and what you'll get into in the future. For this, all you need to know is, what is it doing as it approaches negative infinity? What's the one of the x-intercepts? What's the y-intercept? What are the other x-intercepts? And then what's it doing once it's approaching positive infinity? And then that is the problem. Okay. So I wanted to talk about a couple other things in Desmos about even and odd functions, okay? So I plugged some in here that are even and odd and neither, okay? So the first one, which is the absolute value of x, is the v, okay? That's even. All even functions are going to be symmetrical on the y-axis, okay? And the tables for them, for even functions, are if I have 1, 2, 3, 4, and I have like, let's just say what that one I think is, which is so to spot it from a table, if it's even, it looks like that, okay? I get the same thing for y on both of them, even when I do -1, -2, -3, -4. So if I do like 60, okay, whatever, -60, whatever is going to be, these two are going to be the same value. And that is even, and it's symmetrical on the y-axis. Let's take the second one, which is x squared. It's the blue one, and that one is symmetrical on the y-axis as well. And then the one that we plugged in earlier, the other blue one, which is at x equals 1, that one is not either. It doesn't have any kind of a pattern at all, and neither does the other one. But we should take a minute and think about, what if I add things in here? Like, what if I have the absolute value of x minus 4? Is that even? It's symmetrical, but it's not symmetrical on the y-axis. So that one is no. What if I have x squared minus 6? That's no good either. But then you got to be able to spot it in other forms too. So if I have, like, let's say, I can get rid of all this stuff, I think. What if I have x plus 3 squared? Okay, that one's not going to be symmetrical on the y-axis. Okay, odd functions. X to the third power. There's an example of an odd function. Okay, and the rule for that one is, so for the odd ones, if I have something like y equals x to the third, if I have like -2, -1, 0, 1, and 2, when I plug this in, I would get actually, no, I don't want to do it that way. Let's just use the same numbers that we used on the other side. 1, 2, 3, 4, -1, -2, -3, -4. So I get 1, 8, 27. 4 to the third is 64. When I plug in -1, I get -1, -8, -27. That's odd, okay? So I end up getting the opposite on both. So these numbers are opposite, and those numbers are opposite too, unlike what was going on over here. So you just want to make sure with those that it is symmetrical, or not symmetrical, so much as when we plug in the same values for x and y, that is the relationship. So if it's shifted over, it's no good, okay? No matter where you shifted it, it wouldn't be good, okay? It has to have and maintain that relationship. So hopefully that helped. If you want to practice more, I would continue on 310 and then look on Canvas where I will have the answer key to 310 for you so you can check your answers. But please note that when you look at that answer key for the one that we just did, it does have a wrong answer for it, and I confirmed that with other teachers as well. And hopefully that's just for that one isolated problem and not any more than that. But hopefully you guys found this helpful.